तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
We created deliberate errors in the last class and to see how the simplified tool as well as the model sim tool behaves and how it reports and how it guides us for us to correct it, and we will continue with some more examples of that kind. And let us say this is the source file for sequential circuits, and let us make an error here. So we have let us change the name of the signal. So it is as CLK. I will just change it as clock, and let us observe how it reports. We will start with the model sim here, and so in order to do the compilation we have only to design compile, and we need to take the test bench in order to compile. So let us see, it has reported some error. See, we change the name of clock, so it promptly says that undefined variable clock is encountered here. See, and this is just a warning saying that I have changed the source file. You can just ignore that. And so it opened the source file and is pointing precisely to the place where CLK is used, because this is an undefined variable, because I have changed the name right at the beginning or that right at the input I changed it as CLOCK. So that means that is to say that CLK is undefined. So we had to declare input. So this follows from that, and that's what the error is here. And there is one more error here, and this is line number 214 here. First one, this is 214, and this is 601. One more error is reported here, and that this is 601. And towards the end module it is reporting, but again it is the same CLK, because towards the end of the module it is in the habit of saying that once again the same thing. Okay. And we will revert back to that old one. So we will create one more error of a different kind. For example, we have been using semicolon all along. Let us remove one semicolon. Let us see what happens here. For after input reset, we have removed the semicolon here. So compile once again it reports error here, and this is what it says is it is pointing to input hold, which happens to be the next in line with reset n. That's here we have removed semicolon here, but it is pointing to this line saying that error is encountered here, because just before processing this line this one was absent. So it cannot distinguish between one statement and another. So that is how it points out. It always points out to the next one, just remember that. And most often all beginners forget these semicolons, and this is very usually encountered error. And so we have not seen the corresponding simplified thing, and before that we will see here for this. So it is reporting errors here, and if you view the log file, you notice that it has done nothing beyond that, because the very first shot it has encountered the error, and therefore no further report is seen within this log file, which usually is a very long file. And you can see that error here, this is at E is reported, and what it says is expecting delimiter comma or semicolon, it says. If you double click that, it opens that source file, and once again it is pointing to the very same thing that model sim had pointed. For example, this is input reset underscore n, and this is hold, and note that the semicolon is missing here, and so in both the cases it is precisely the same. And earlier error we did not create for the synthesis tool, we will do that as well. So we will restore this semicolon here, and clock we had OC introduced there, and so we will run this again. Once again it is reporting error, and let us see where it is. It is once again same, except that this time it is reporting differently. Signal clock is missing from port list, that is what it says here. If I double click, it goes to the precisely the same statement, input clock CLOK, it is highlighting here. So simplified tool is marginally better in reporting compiler errors. So we will create one or two more. One more error is, see, for example, you can have so far we have been dealing with only single bit precision signals. We can have a multi-bit precision signal to see whether any changes there. See, for example, this counter reg is 7 through 0, and let us remove this and see what happens. So just an indicator that we have created the error here, just putting there. So now let us see this simplify and run that. It is reporting error. So you can signal clock is missing from port list. Is that the error that we had? That is not the one, right? So let us find out why it is. that is because we have not corrected here. So, this error you should deal only with one error at a time. So, going back to Simplify Pro, let us run again. So, it has not reported any error this time, but warnings are reported. Let us see what the warning is. See, this is the warning here, and the warning says range of port counter reg in port declaration and body are different. So, right at the beginning what did is this for the count reg, isn't it? And 7 through 0 it should have been. So, we removed that one. So, but elsewhere we did not remove. For example, the same thing is declared as count reg, reg. Let us find out where it is. We can just find out from here. That is the one. So, it should have been, we have changed here also. Earlier we changed, so it's mismatch, that is what it is reporting, right. And if you do this same thing in model sim, what will happen? It does not report any error. Perhaps it will report at the time of loading. You just see, load and see. It is reporting warning here. What it says is too few port connections. That is what it implied, and it is also reporting this. I think we have already seen earlier. And all along we have been looking into the design file. So, let us have a look at the test bench. We will create one or two errors there also and get a feel of it. And test bench is here, and so we will not repeat what we have already seen, for example define, etc., and module. So, what we will do is, I was saying, pointing out that inputs or outputs are differently declared. Here it is reg instead of wire normally. So let us declare this as wire and find out. So, it is reporting, model sim is reporting error here. See, what it says is illegal reference to net. It's if you double click, the source will open. So, where did we change? We have changed for D. So, this was supposed to be reg, but we deliberately made it wire. So, it is promptly reporting here, right. All of them are with reference to D at various points of reference. At 4 places it has been called. So, the error says it gives the path name of the file up to this, and it gives the line number here, and this is some 153 line number, and that is precisely what it is here in the open file. And it is reporting there because D has been referenced, it has been forced to 1 here in the test bench, and because it is illegally declared as wire instead of reg, so it is promptly reporting. And what it says is, after the line number it says illegal reference to net, then colon D. D is the signal under question. And similarly in simplify you can see. Oh, we can't see. right. This is a test bench, mind you. So, there is no meaning in going for the synthesis, right. So, that by now I think it should be very clear where, I mean, synthesis only the design is allowed, right. And before we wind up this error creation, so we will consider one last example, and let us go to the very end, and you see here. And another point is, once you have done all this, it is a good practice for you to copy relevant details from the simplify results and place and route results into the same source file for as a ready reckoner. For later use, you can you will very easily know how many get count it has taken this particular design. So, in the design file you can just make a copy, that is what is shown here. Along with that, you can see all that. So, before, what we will do is, we will many people after writing long codes, they invariably forget one end module. So, let us simulate that also. I do not have to remove that, I just comment it, which is equivalent. So, now let us see what it does. So, it is a reporting error once again here, right. So, near module syntax error it says. It does not really throw much light, you have to make a guess, and it points to the module top rather than at the end, that is a thing, right. You have to herald a guess on that, and let us see the simplify. Will it work for simplify? Don't, because we are on the test bench, right. So, we have made the change only on the test bench. So, I think with this you must be confident tackle all by yourselves any error that comes. So, the best thing would be to copy the codes which is working. So, namely, if these codes are available to you, you can make a copy into a folder, and then experiment in that file rather than tamper with the original source code. So, next we will move on to we have been dealing with RTL coding guidelines. So, we have covered synopsis full case, then synopsis parallel case, etc. We will take up those files independently and see how the optimization really works, right. Let us have a look first at the source code for the full case. This is called the full case here, and the program is quite simple, and what we have here is 3 inputs ABC, and one select pin is also there. It is basically a case implementation, and synopsis, this is the special thing which I have mentioned earlier in the while dealing with the RTL coding guidelines. So, that is after comment you use synopsis, then space, then full underscores case. So, this is a reserved word here, although it is looking like a comment, but this is a reserved word. So, you cannot put a comment which resembles this, or instead of this you cannot put a parallel case also. So, 2 are reserved. So, what is the specific advantage in having this? We will be having a look, right. And what this code is supposed to do is simply assign A, B or C to out, right, depending upon the select pins. For example, if it is 001, so we have seen this as for one hot machine we can have like this. So, in one hot machine there will be only one entry 1, and you can see 001 only one entry, one here and one here. So, in this case default is commented, not right now not used, and I will see it later on, and the whole thing infers a mux. This also we have seen, and it is also applicable for a one hot machine, and let us run this code, and that is all the program for this. So, let us go, we are not going to invoke model sim for this, only this simplify. So, model sim I will leave it as an exercise for you to do. So, for this what we need is we need to create a new project, let us say. We will now see the simplified results for this full case, and so this has been done already and prepared already for you for all the different cases. So, right now we are in full case, and let us view this RTL view is this one, and you notice that there are only muxes inside here. As I mentioned before, D stands for data and E for enable, and what you have here is A, B and C through 0 bit. So, that is 3 bits each, and there is a select which is also 3 bits. So, in fact this select is distributed all through as 0 bit here, then 1 bit here, 2 bit here. In fact, they are all inside basically 2 input muxes, which we can see by technology view. So, this is what it is. See, for example, let us say we zoom it here. So, you can see I buff, this select to 0 is used here, and all inputs are appearing on the left here. Through I buff it goes to different mux here. And basically they are all 3 input LUTs used, and finally there are output buffers here. So, when you zoom it down, so you can see it very clearly. So, basically there are 6 LUTs, and functionally they are 2 input mux, as you can see here, and output buffers are this, and then input buffers here. So, if you see this and compare it with another case, for example, this is the result of what we have been seeing is full, this is the one, and which uses synopsis full case, and there is exactly the same thing, and we remove that synopsis full case and we call it just no full case, right. So, let us see, otherwise the code is exactly the same, only difference is we have not we have removed the synopsis full case here from here, and here in this case we have also mentioned earlier that it infers some latch. Let us run this in simplify and find out whether it is so. So, now we will just minimize this, and this is the RTL view, this also will minimize, and so what we will do now is we will go to no full case, that is here, and the corresponding RTL view is this. So, what we had earlier was actually this one, and now this is for synopsis full case, and whereas for no full case, so you see that in addition to this extra gates have appeared here. So, 3 plus 4 gates plus one latch is also there, and latch is detrimental for making a really working hardware. We have pointed out earlier during the RTL guidelines. So, in fact that is what you see here, and synthesis tool does not remove this as such, but it gives you a warning. I hope there is a warning message corresponding to that. but all said and done you can just see just by giving that synopsis full you save so many gates including the latch, right. So, that is quite a substantial saving, and if you can also view the once again it is same 2 plus 2 4, then 6 here, one extra LUT has come over here, and again this count input buffers and output buffers may essentially remain same, and only this it has made a difference, and plus you see that latches here. See, all LDs are all latches, 3 additional latches have been created. So, only if you look into the technology view you get the real story behind that, and we have so far seen case full and case no full, and pointed out that we can effect substantial savings and just by that directive, and similarly you can have a parallel case and no parallel case, and the parallel case is once again similar to that full case in the sense that case is being used, and in a slightly different sense here. For example, select or A or B or C. So, any of these combinations inputs if it is encountered, then out goes to is forced to a particular value. So, it was different in the last full case, here it is slightly different. So, this is once again here notice the difference here. So, here it was select earlier, but now it can be even A, B or C. If select is equal to A, then it will come to this point. Similarly, for C, if select is C, then it will execute this. So, in this case this is called a synopsis parallel case. You notice that once again this directive is important, there should be no comment of this nature, and here it means parallel case means no priority. So, this also we can see. So, how a priority comes and where it does not, right. So, let us see this. We will run the simplified thing for this. So, we do not require this also. So, we will go to this parallel case. This is parallel case, and all this have been run and kept ready for you, so that we are merely viewing that. So, we will first see in this is a parallel case, and what all it means is, so when you look at the code, what it says is when select is equal to A, then out is 1 and so on. It is all with reference to select and the actual inputs, and that is here if you see this is C, this is B and this is A, and all the 3 bits. Similarly, this is select. So, A and C are select and C are compared here, that is why an equal to symbol, and straight away the output is set. So, what should be the output? So, that is governed by the code that you have already written, that is here, right. This is not plain there, and so is the case for select equal to B, select equal to A. So, it is primarily this, and this is the technology view. So, once again you see all the inputs have I buffer and then outputs O buffer, and then you see LUTs being used here 1, 2, 4, 6 LUTs are used. Once again these are all input buffers, and this is a parallel case. And now let us have a look at the no parallel case. So, the no parallel case code is exactly the same, except that this synopsis parallel case has been removed. So, that was what we had here, synopsis parallel case. In this case only that is removed, right, otherwise it is same. So, now let us look at this. So, this is the parallel case for which this RTL view is this. You see that for earlier case it was only 3 equal to there, now it has created additional gates, 3 gates are extra here, right. So, earlier it was only parallel case, right. Or we can remove from here. So, it was this, and now in addition to that you see 3 more gates. So, that is the difference, and once again this technology view will reflect exactly the same thing except for details here, which you can see. So, you can see, and as usual you can go into that if you want to get all the signal details here, and you can come up again. Here also you can see the signal details by removing this, as I mentioned here. This may be tedious, it is better to use this and then go in and do that. So, what we have seen is no parallel case, and here we have seen that here also extra gates are put in. So, I will leave it as an exercise for you. Suppose you remove this, comment it and run and notice what the difference is as far as the mapping is concerned, right, whether it takes more gates and so on. So, also for full case you can uncomment this and run, right. So, okay. We have so far covered model sim for simulation and simplify for synthesis, and we have also seen in simplify it produces an output called .tdf file with the same design name that you have specified, and that should be input for the next stage, which is called place and route. We will be taking only a Xilinx place and route in order to demonstrate this total design flow, and here we have this simplify window opened here already, and we have earlier used for sequential circuits. One of the revisions is here, and which you saw an RTL view of sequential circuits. It's too large there, and now what we are going to see is how we invoke the Xilinx place and route and learn about the tool. So, we have an options here. So, just click on that options, then you are the tail end you will have Xilinx, and once again within Xilinx you move on to this, you have start design manager, start floor planner, then start ISC project navigator, and in Xilinx place and route what design managers do not seem to be coming in the recent revisions, only project navigator is available. So, but I am going to show you on design manager because you can get a more feel than the project navigator, and it should not be difficult for you to migrate from design manager to project navigator. What all you need is a couple of hours of familiarity. So, we will start the design manager by clicking on this. So, you see that new window has opened. This is the Xilinx place and route. So, now what you see here is we have the input for this Xilinx place and route is that .edf file of sequential circuits, because we invoked from the simplify. So, it had automatically opened with the relevant design file, and it has also created one version here, version 1 and then revision 1. So, as I mentioned, in order to avoid overwriting, these tools normally they do create different versions, revisions, and that is how you have here. And now what the next step here is, the place and route already knows that the input file is sequential circuits .edf, and this will be taken as the input file and processed further. So, what we had to do in order to do the implementation is, there is one arrow here, just click on that, it also says implement here. Otherwise, from file also I think you can have, or in design you can have implement, that there also you can have. You can start the place and route by clicking on this button, an arrow button here, and prior to doing this we will create a new version, because this has been already implemented, revision 1 has been already implemented. So, we will start a new version. If you click on design and then you see here a new version, you can create if you wish, a new revision also can be created. Let us say we go for new version. So, you just click on this. So, what happens is a new version window pops up, and it is earlier it was version 2, now it is version 3 here, and you see the device that we have selected is right here, and we have a zoomed picture of this. We will have a look at that. And this is the new version window, and herein you see the device that has been mapped. Here it is 50E. We can change even at this moment, and input file for this place and route is going to be a sequential circuits .edf file which we created in the synthesis. In fact, we had come directly from the synthesis, therefore you do not have to specifically mention the input file name. It automatically takes .edf generated in synthesis as the input file here, and although it is showing revision 1 here, I think it is revision 3 what we have we are going to do. And now notice that we have what is called constraints file. We had to give constraints such as timing constraints primarily here, and there are pin constraints also which we will be seeing in future. To start with, we will see only the constraints file, and you have then floor plan, guide files, etc. For time being, ignore all this. And before this, we will just have a look at, I have already summarized these commands, and let us have a look at this summary here. This is the place and route we are talking about, and the specific enter is Xilinx, because you had to be very specific about the vendor, being since you had selected the target FPGA as Xilink 50E series, 50 standing for 50,000 gates. And next step after place and route will be what is called back annotation. Only here the actual gate delays etc. will come into picture, and subsequent to this you have to take back annotated file which is also a .v file, and that will have to be taken into the model sim simulator and run once again the simulation run, and satisfy yourselves regarding the functionality is concerned, and therein you will get actual gate delays reflected. And I will just read out this particular first step that we need to take. In simplify main window, click on options Xilinx start design manager. This is what we had done earlier. In order to invoke the design manager, the Xilinx design manager window opens. Sequential underscore circuits.edf created by synthesis is automatically taken as the input file by the design manager. That is what we had already discussed. And also another window called new version opens, and we opened it rather forcefully here, and had you done it at the very first time, it would have automatically opened that. And choose custom in constraints file. So this also we had just now seen what a constraint file is, we are yet to see, and the field we have seen just now, and in that you had to select custom, and another window called constraints file also opens. Using browse, select the relevant sequential circuits.ucf file. UCF is user constraint file. So it is if you look at this file, you will have it is this file either you create it or the place and route tool also can create it. And let us I have already this file made, so we will have a view of this file, and after this click on open. Then you may have to close two windows, therefore you have to say twice OK, and if everything is OK in this Xilinx design manager, revision 1, probably revision version 3 now, and maybe revision 1, and in the very first time you had you do it will report in this fashion, new OK will be displayed. So, it is slightly different from what has been mentioned here, and let us go to the actual tool. So, this is what we have seen herein. It says version 3, and for regarding the constraints file, what it says is last revision version 2 is being taken here. Actually, what I should have done is there is one thing called custom. So, if you just click on that custom, so it will ask for the actual file. You can use browse here and then go to that particular folder where you have already located the UCF file, and then click on that, say OK. So, if you do that, I will just cancel because it has already been taken earlier, and that was this. So, that is what you have to do for constraints file here. This also a zoomed version is available here, we will have a look. This is what we have here, this constraints file, and we had just seen there is another window popped up, and herein you mentioned the file name UCF. In fact, you do not mention, the system will do it for you. What all you have to do is just use this window, go to the required folder where you have placed this UCF file, and then click on that. It will list all the files, especially UCF files, because that is what we want here, and click on the relevant file. If you click, it will appear here, and then say open. So, once you say open, it will appear here, and then you can say OK, and that is what it is all about. So, what we will do now is we will go to the Xilink's main window and start running the OK. So, this is version 3, and here it happens to be 100E. I have changed the device here. So, instead of 50E earlier, it is 100E, and this constraints file just now we have seen, it is a previous version which is exactly the same sequential circuits UCF file, and once you are satisfied with all this, just say OK. So, version 3 revision 1, and here it reports new OK is created. Now, what we have to do is we are going to start the place and route. So, the input file for this is sequential circuits .edf generated by synthesis tool. We will click on this in order to start this. You see a new window open up here, and some activity is going on now. You can't read this file anyway, and we will see later on a zoomed version of report files. So, right now what you see that this is over and this is also over. The first one is called translation, which translates the input file, that .edf file, and then once into a format compatible with its own tool, and then actually maps the different primitive cells, etc., including the device, and within the device all the primitive cells which we have already seen. So, and after that, unfortunately it went too fast. What we will do is we have a zoomed version here. So, once this step is completed, mapping is completed, this also will darken here and also mention that it is already completed, just like this. And this is a laborious process, place and route. So, what we have done is selected the device, and then within the device all the primitive cells it has placed inside, and actually it is not totally actual placing happens only here, and it places all the primitive cells at a strategic points, considering what is best in terms of frequency of operation that you may get. It always has an eye on the frequency of operation, and once it is placed, then it starts the routing. So, all these inputs are provided, mind you, by the .edf file which we have already seen, and based on those inputs it will start routing from one pin to another if it is external pin, and in fact to the inner pins for the functional modules I mean. So, primitive cells also will have its own IOs, they are not actually the pins, but the functionality within. So, all those things will be taken care, and it will do the routing, total routing here. This is a very time consuming process. To give a similarly when you run the synthesis tool also, synthesis will also take quite substantial time if it is your design file is very large, and so is the case here. In fact, while placing and routing, it will take much more time than even synthesis tool. So, I have personally experienced for over 3 million gates designs such as video scaling. It has taken over 72 hours, and in both synthesis as well as place and route. So, it is just to give a rough idea how time consuming the process is, and more the circuitry, more time it will take, and for this particular thing it has hardly taken a minute or two, and this is a very small design. And once this place and route is completed, so this also will darken, and then final configuration will be done. So, overall configuration, right, and we will go back to the Xilinx here. What we had to say is we have lots of information available, and say there are reports files here as well as a log file here. So, whatever was the process reported, it had you remember that it had reported online when the place and route was going on real time, it was continuing to report. So, all those reports will be compiled and be available here, view log file. So, we can have a look at view log file, and so that we can understand. So, this is the log file. What I will do is I will just copy a portion into the document file, so that you can view it. So, from this they have inner processing. So, let us not go into the details of this, and it has taken XCV100 as the device that we had already mapped in the synthesis, and we also gave user constraint file. So, this is the option here for that, and we really do not have to worry about all these commands unless you give it from DOS. So, here what is essential is what they mean. So, basically it has a constraints file which is what we have given, and next is your EDF file, that is what is reporting here, and it was revision 13 earlier in etc. Folder that we created this sequential circuits.edf file, and it has also created another file called ngd, that is what is happening here. So, let us not worry about this inner details, which will be required for further processing and place and route, and this is I think it is same command here. So, just again very same information is available at more than one places. So, you can so it has also to read from libraries regarding all the primitive cells, etc. Then okay, finally what it says is it is not final thing, it is just starting of the report file. So, this first phase is over and it found no errors, neither any warnings here. And then it is creating a file called sequential circuits.ngd and a log file with this extension, and many other files will be created. And so this what we were viewing here up to this. So, next step is to map the actual device. So, there is another command here, and this can also be used in DOS command mode and executed here, and it takes the previously generated files here, and this is once again a constraint file, and it is writing into a map, it is creating another file here, and okay, some delay information if at all, and any packing information, all this, and one more file is being written here. And even during this stage, it reports number of errors and warnings and number of slices. I mean, the design will take different what is called as slice. Slice could be, I mean, this particular thing is 100,000 gates. So, and number of slices that you can have is 1200. So, I know what a slice is, how big it is, and a collection of so many LUTs and so on, and that will form the slice. So, it reports in terms of slice and number of flip flops that are required out of the maximum here, and the percentage of utility is mentioned here, and then you have 4 input LUTs. That also only 73 has been used for this particular design, which is sequential circuits out of 2400, and this is 4 input, and perhaps other number of inputs are reported here, and some IOBs, IO buffers, and then flip flops and clocks, all that are reported here. And finally, you see one more thing interesting here is we can talk in terms of total gate count. So, only Xilink has this provision, you do not have it in synthesis. So, in a nutshell you can understand how you have, and there is one what is called JTAG, this to comply with the standard for IO connections, and that also will assume take more gates. So, we will see further thing we will continue with this in our next class. Thank you.